Okay, good morning, everyone.
Good morning.
Yeah, morning. Yeah. Um, Before the class, I think I just want to um, mention that I have already uploaded the assignment two, and the assignment one sample answer is also uploaded. If you have any question, just send me or Tia an email. And I also uploaded a Python quick starter document. So in case some of you may not be very familiar with Python programming, okay, it's important for the next assignment. Not always, I mean, we are using Python for assignment, but at least for the next assignment, we need to use Python to do the socket programming. And today I will cover the socket programming, right? Some general or basic idea. So if you are not familiar with Python, so please take a quick look at the document. And I think some students may ask, okay, so nowadays, usually everywhere people are using Python 3, right? But for socket programming, the library or some tutorial are still based on Python 2. So, I mean, the Python 2 should be the base Python in your MacBook or a Linux system, right? But if you are in Windows, maybe you need to install separately. But anyway, I think for the socket programming, let's use Python 2, okay? And today I will, start talking about some socket programming, okay, from TCP and the UDP perspective. And I will also show a demo so that maybe make you understand better. Okay, so let's start our lecture today. So here is the new content we want to cover today, and then we will finish the chapter 2, okay, application layer. So for this sub-chapter or subsection, we're going to talk about socket programming. So I think you still remember what is a socket, right? Generally speaking, it has an IP and the port number, right? We are using the socket as a door to send and receive the message or data, right? So that's a quick summary or brief summary of what is socket. So what is the purpose of socket programming? Okay, the goal is to learn how to build client and server applications that communicate with using the sockets. And the socket, like I as I mentioned, it's like a door between application process and the end-to-end transport protocol, right? So you send and receive everything through the socket. And generally speaking, socket includes IP and port number, right? As we mentioned before. But I will, as I mentioned, I will do a demo. So in the demo, you will see that need to give the I mean, in the local machine, IP is just the local host name, right? But if you are using the two different machines, you can use the IPs with the port number. Okay, I will show that later. So this is the purpose of the learn to learn the socket programming. And generally speaking, we have the two socket types for two transport services. As I mentioned before, we have the UDP, right? It's the unreliable datagram protocol, right? And for the TCP, it's a reliable byte stream oriented transport protocol. Okay, so I think you still remember we have a table, right, to describe what kind of the application can use UDP or TCP, right? Still remember that table for some email, text download, something definitely you want to use the TCP, right? But for video, for the some streaming conference, maybe you can use UDP, right? So there are different applications can use different protocols, I mean, with different socket programming types. Okay, so for example, this is the example of the application. So client can read a line of characters or data from its keyboard and send the data to server. So here we describe four steps or higher level procedures. Then we will show the demo basically based on this procedure. Okay, so just keep in mind we will do it in the demo. But the idea is that the client reads a line of characters from its keyboard and sends the data to server side. Okay, and the server receives the data and converts the character to upscale, and the server sends the modified data to client. Client receives the modified data and display the line on its screen. It's just like one times of a send and receive, right? You send the data, the server receives the data and convert the data into uppercase, right? And the reply or send the data back to the client. Client displays the converted data or message, right? That's what we will demonstrate. And I think also this is our first maybe programming style assignment or some demo, right? Because previously we haven't got any chance to give you an idea about how to program. So we are still a computer science class, right? So programming is a kind of our key goal. So how to do our circuit programming is kind of important. I will show that later, but for the next assignment, it would be based on a circuit programming, okay? And for the circuit programming with UDP, as I mentioned, you have two transport protocols. That means the circuit programming should have two different schemes, right? For the first is pro circuit programming with UDP. If you still remember, UDP doesn't need to establish a connection between client and server, okay? So no handshaking, no connection needs to be guaranteed between the server and the client. Okay, you just send the data and the client, the server would receive the data. Okay, no handshaking, no connection established. Okay, so the sender explicitly attach the IP destination address and the port number, right, to each packet. And the receivers extract the sender's IP address and port number from received packet. Okay, so that's just a send and receive, right? No handshaking, no connection, established connection. Okay, so this is a very important part you need to remember. And for the UDP, transmitted data may be lost or received out of order, right? Because there is no order guaranteed. There is no guaranteed for um, um, send and receive, right? Because there is no connection. Okay, there is no handshaking. So from the application point of view, the UDP provides unreliable transfer of groups of bytes, datagrams, right, between the client and server. Okay, so let me show you the whole procedure before I go into the code, before I go into the demo. Okay, so the whole procedure is that from the server side running with the server IP, right? First create a socket. So still remember the socket is just like a door, right? Everything go through sender receiver need to go through the socket, right? So everything start and end with socket. Okay, that's the key point. So first you need to create a socket. The socket needs to have a port, right, port number. And you can see here server socket. And this socket function, I will show you later, but generally speaking, this socket and AF int socket diagram, this something is just like API, right? This is a function call. So this function is provided by the Python socket library or module. Okay, that's why we are using Python, because Python provides us a socket module or library, right? So you can import that module or library and then directly start socket programming. Okay, for example, here you want to use a socket, that's the API, right? That's provided by Python. So generally speaking, at the beginning, you need to import a socket, right, module, and after that, you can use that. So you use a socket, f int, and the socket diagram. So we will explain the syntax of each function later, okay? But here, general idea is let's first create a socket. So after create the socket, client also need to create socket, right? Socket both sides, not only one side. Both sides need to create socket similarly, and you need to create a datagram with server IP and the port number, right? Send the datagram through the client socket. So you have a server socket and the client socket here, right? But both can use the socket function to create. Okay. And after you create a datagram with server IP and send the datagram through the client socket, and the socket from the server side can receive the data, right? Read the data. So using the server socket side, and you convert that data or datagram into the uppercase, okay? After you change something, you return or write reply, so a server socket specifying client address and port number, you send the data back, right, from the server side. And the client side read datagram from client socket and close the client socket. But the server side socket is always running there, right? Because you are not closing that. It's a server side, maybe another message will be sent there. So server side is always running there. Okay, so let's quickly see the code, okay, for this procedure. Okay, so I think this is quite simple. We just create a socket and send the data through socket to the server side. Server reads that data through socket and change the data and change the data back to the client socket, and socket closed. Okay, it's just straightforward. Okay, but how to program this? That's what we want to learn here, right? How to program. Okay, so let's see how we can program. So for the code, as we are using Python, right? So first you need to, for example, here is the UDP client. Let's first program client. Okay, so for a client, as I mentioned at the beginning, you need to import the socket module or library provided by Python, right? Python 2 has already got this module. So you can use Python 2 to import this socket, okay, socket module. After that, you need to give the server name. It's like a IP, right? So for example, if I'm only doing in my local computer, generally speaking, you only need to give the IP address as a local host. Okay, I think there should be a local host without any space here. Okay, local host. But it depends on the name or the host name of your laptop, right? So my laptop is a local host. Some Linux system is also local host if you don't change, right? So the server name is local host, and server port is the 120 sorry, it's 12,000, right? 12000. So it's a server port number, and after that you just create the client socket here. So let me change to a laser pen, laser point. So here is after you specify the server name and the server port, you just create the socket. Okay, so for the AF innet, it's just like you have the AF innet, or you have a AF innet v6, right? It's just the IPv4, IPv6. Generally speaking, we use AF innet, right? This is a family of the IP address. And then you give the socket the datagram, right? So that's how you create the socket. Let's see the note here. Okay, so first they include the Python socket library, and then you create a UDP socket for server. Okay, so this is a for server. I mean, in client side, you need to let the client socket know uh, the I think it's not create a UDP socket for server. It's for the client, right? Here is a typo. Sorry, let me quickly change this. It should be a typo, I guess. Okay, so you can still see my screen. So Yes, this is a create socket for client because this is a client code. Okay, and then we can see the get user keyboard input. So after that is you just need to because you are a client, right? So you have to ask a user or yourself, right, to input something. So based on our application description, right? The application is that the client side input some sentence, some characters, right, and send that characters to or datagrams to the server side, server convert. So first you need to get some characters in client side, okay? And after that, you attach the server name, port to message, and send into socket. So here is a message dot encode. So message you is a Python object, right? You strings or characters, right? You got from client and or yourself, right? And after that, you call the encode. I think this encode is a function provided by Python socket library, right? Encode could be Huffman encoding, could be any data compression, could be anything, right? This is encode. As we mentioned before, this also could be secured encode, right? Encoding, right? So but anyway, this is some encoding algorithm here. It's transparent to us. We don't need to understand here, okay? But just encode something here before sending the data, right? It could make the data less sized, right? So, and you give the server name as we mentioned here, the local host, right? It's kind of like an IP address, and the server port is 12000. Okay, this sends this data to the server side, right? And I think next step should go to the server side, but let's assume that server already got something, okay? And the server reply you something. Okay, so after that, you should receive something from the server side, right? So you can see modified message and server address. This is the two return values from the client socket received from function, okay? So you can receive, because at the same time you can receive a different message from different IP address. So it's important to have a return value for the server address, right? And also modify the message. Modify message means, as we mentioned in application description, we change the lower case to uppercase, right? So you will get the new message or a converted message and you print that, okay? And then you close the client socket, and that's it for client side, okay? Bring out the received string and close client, close socket. So that's code or Python code from the UDP client side. I think generally speaking, it's quite standard and not complex. Let's go that again. So first import the Python socket library and specify the IP address, localhost, and port number. After that, you create a socket. This is quite standard, right? You just use a different client socket, the name you want, socket 1, socket 2, socket 3, right? Whatever you want. And you use a socket API, right, to create a socket. And after that, you just get any sentence or character or strings you want from the keyboard, right? This is something like a standard IO, right? And after that, you just send the data. So you use a socket, right? This is socket you created, and send it to is a message. Oh, sorry, is the API from the socket modules, right? You send that to the specified server name and port number. Okay, after that, you get something, receive something. You can see here is sent to this receive from, right? Receive the message from the server side, and with the modified message and the server address, you just print that close. Okay, so this is client side. Let's go to the server side before you forget about the client side, okay? And this is a server side. Server similarly import the library, right? Give the server port number, okay? And for the server side, you can give the name, but it depends on the system, right? Let's call it local host. You know what's your address, right? And for the server side, you create a UDP socket, and you bind the socket to the local port number, right? This is important step. You need to bind the socket, right? And after that, you just print that the server is ready. Okay, let's do anything with the clients. Okay, I'm ready. I just waiting for the client to send me some data. And then you go to the loop, forever loop, because you want to the socket or the program to forever running there as a server, right? Server, you need to always serve there. So forever loop. And after that, you read the UDP socket message, right? So it's similar receive function, receive from function. Remember, receive from function, and you get the client address and the message, right? You modify this message. You first decode, then you upper, right? Upper is uppercase. So I mean, Python has given you a lot of good function, right? If you program in C or C++, maybe you need to program decode. You need to program upper, maybe not upper, but at least the decode, you need to include some library, right? Otherwise, who knows what kind of the encode and decode algorithm you want to use, right? And after that, you have the modified message. You send the modified message encode to the client side, okay? And if you compare with the client side algorithm and the code, you can see that after you receive the message, you decode, right? Send some original data, decoded, right? And receive some data, sorry, encoded and receive some data, and then decoding, you print, right? That's a server and client code. So I'm going to do a demo. Before that, any question? So I'm going to show these two codes, how they communicate with each other. Okay, so this is just uh, this is the code we can run definitely. Okay, so before that, any question about this scheme? Send and receive using the UDP, create socket, send to, receive from, print, encode, decode. Any question? This port number is created by you, right? You can use any other port. So as we mentioned, HTTP has the port what 80, right? So this is some standard or people are always using the port number, right? In the standard, right? But here, whatever port you want to use depends on your setup, right? For example, the server side set the port 12000. So the client side will use this port, right? This is the server port, right? This is not the client port. So in client code, you give the server port, you can change to other port, right? Yes. So I will show that. So sometimes if I end the server side quickly and relaunch, sometimes it rejects me to relaunch because it says that this port has been still dominated by the other blah, blah, blah. So you cannot use this port again. But if I wait 10 or 20 minutes, sorry, not 20 minutes, 20 seconds, then I can use that. So I can do that demo. So if I first launch server and I Control plus C to secure that, and I immediately relaunch, and then the code maybe give me some error message saying that the port has been already being used, right? That means the bind has not been deactivated. Okay, so that's a good finding if you do a demo, and you will find some very interesting thing here. Okay, so definitely I can use any port number I want to use, right? Here I use a very large number for the port number because I want to avoid with some standard thing, right? 80 or 40 for email or something, right? So you just write some big number here. Okay. So if you don't have question, let me do a demo. Can you see my screen for the two terminals. I want to make sure you can see two terminals, okay? Two terminals will give you an idea. One side is a server, one side is client. Okay.
I can see both.
Okay, very good. So let's say this is a code I have, okay? So for the, let's first go to the UDP. Let's see, this is the client side, okay? Right-hand side is client side. This side is server side. Okay, exactly the code I show in the side. Okay, the port number is the same. This is the local host, ready, and forever loop, receive, change the message and send the message back. Okay, this is the create the socket, message input from the keyboard, and send the character strings, and receive the modified message and print the modified message, client closed, client socket closed. Okay, so let's say if we first launch the UDP server side, right? So the means the socket has been created. It's in the forever loop, right? Waiting for something. Okay. So this is the client side. Okay. So it's waiting me to input something. Let's say hello world. Okay. Every time we're testing everything, let's do hello world. Okay. So after I enter, that means I have this server side received the hello world and it's in uppercase, right? But nothing changing in server side because in server side, you don't print anything, okay? So let's try to kill the server. Okay, let's try to modify the server. For example, if you receive something, what about, let's ask it to print something, okay? Otherwise, we don't know it's received. So let's print server receive what? Receive the message, right? And let's also add something here. Print server send. Send something. Send what? Send the modified message. Okay. So we want to server to let us know, right? So what happened? Otherwise, it's unchanged, always there. So let's launch the server. Okay, and launch the client. Okay, we also input hello world, maybe 2. Okay, so after I enter, you can see immediately it received the hello world 2, server send hello world 2, and I received hello world 2 here. Okay, so you can see it's almost, let's do another client, right? Go cogs. Okay, oh, I should use the lower. Okay, go cogs. Okay, so okay, go cogs. So yeah, that's a demo, right? Quite interesting. If you haven't got any experience about socket programming, but this is the UDP socket programming, and it's in my local computer, so I cannot experience any data loss, right? It's just in my laptop, so TCP UDP should have some same effect here. Okay, but generally speaking, that's the demo. Okay, any question about this demo? So I will show a TCP demo as well, but it's just similar, right? From the demo perspective is similar because the TCP and UDP, the only difference is establish the connection, right? So here I don't care about established connection because in my local host, no data would be lost, right? So this is demo. So maybe let me quickly try. I kill it and immediately launch it if any problem. I kill it. Oh, that's okay, seems like. But if I use a TCP, maybe not, because previously I think it seems okay. But I think yesterday I experienced that if I kill it, and it will let me know the socket is still be dominated. Okay, but anyway, I will try it later. But the bind function, just someone asked, it's to make the socket and the port bind together. Okay, sometimes if you have already bind that and you cannot immediately use that socket, sorry, the port. Okay, so this is UDP socket demo. Let's go back to the slides. Okay, let's quickly finish the TCP. Almost the same. Okay, almost the same, except the established connection. So for the TCP socket programming, client must contact server. The server process must be first running. Also, the something we just demonstrated that, right? So first, the server process must be running, and server must have created socket door that welcomes client's contact. And the client contacts server by creating TCP socket, specifying IP address, port number, and port number of the server process, right? When clients create socket, client TCP establish the connection to server TCP. And when contacted by client server, TCP creates a new socket for server process to communicate with that particular client. Okay, so this means that the TCP has to create multiple different sockets for specifically particular client communication. Okay, allow server to talk with multiple clients, right? So you have the different socket, you talk to different multiple clients, and the source port number used to distinguish clients. Okay. So from the application point of view, TCP provides more reliable in order by stream transfer between the client and server side. This is a description, but I know the CS or E student, maybe you prefer to see the code, right? Code give you, maybe some of student may have the better idea about code. Let's see the code or the procedure, right? The procedure is that you create socket on the server side, given the port number, and then you wait the incoming connection. So this is a step that UDP doesn't have, right? UDP is just wait for the message. The TCP is you need to wait for incoming connection request. Okay, and the client side, you create the socket, you specify the port number, you specify the IP address or host server ID, server name, and after that, you establish the connection or for the TCP connection, right? And after you establish the connection, then you send the data, okay? You send the data. This is exactly similar as a UDP, right? You send a request and the server side read the request and write the reply, and the client side read the reply and close the client socket, and the TCP, then server side close the socket. Okay, I think the lower part is almost the same as a UDP, right? You send and receive encode and decode, and whatever is the same. But the only difference I think here from the programming perspective is you as a server, you need to wait for incoming connection request. You have to wait somebody to tell you, okay, let's connect it, right? And from the client side, if you know that someone connected, then you send the data, right? For UDP, there is no such thing, right? You just send and just receive. Okay, so let's see from the code perspective. As I mentioned, some of you may prefer to see the code. From the code, you can see this is the same, this is the same, this is the same, right? And difference is that client socket side, you need to have a connect, right? Establish a connection. And this is next line is the same, right? Input the data and you send the data. This is the same. And you receive the modified data, print and close. So from this code, I can say that the only different line is the client socket connect, right? This is the same, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I think 9 lines are the same, right? Just exactly as a UDP, but the only difference is this one line is you establish the connection between the server and the client side. And as I mentioned, the AF innet is an address family that used to designate the type of addresses that your socket can communicate with. So for this example, we are using Internet Protocol v4, right? So some of you may heard that IPv4, IPv6, right? So so here you just let the socket know we are using the IPv4 address family, right? And I think for our assignment or Europe or Europe programming, the IPv4 is enough. And that's it. That's for the client side. It's almost the same, right? Except one line. And for the, let's quickly go over the notes here. So the create TCP socket for the server, no need to attach server name port. Yes, because this is, you have established the connection, right? This socket is specific for you, so you don't need to have the server name and port. That's maybe only two different, right? From the line, this is the actual line, but from this line of the code, you don't need to specify the server and port because connection has been established. From the server side, also you need to first create the socket, and the bind is also the same thing. The bind is used to associate the socket with server address, right? Also port number. And this is some extra line. So socket listen, right? Server begin listening for incoming TCP requests. Without this line, server doesn't expect to receive any TCP request, right? You have to tell server that you should expect the TCP request, right? After you receive the request, just establish the TCP request connection, right? And then this line is the same. This is the forever loop is the same. And the connection is a server waits for accept for incoming request, new socket create or return, right? So this is something you need to add is a server socket accept the incoming request. And the other several lines are the same: connection receive, decode, and change to upper, and connection send, send the converted sentence, and close the socket. For the UDP, we don't connect the socket because that socket could be used for multiple clients, multiple client side address, right? But this is, as we mentioned, this socket is specifically for the server, the specific server. So after you finish the connection or communication, you just close that, okay? So let's see the demo again. Oh, okay, let's see the demo again. Oh, okay, so this is also our window, same thing. The left-hand side is the server side is TCP server. This is a TCP client. Okay, let's see the code. Exactly the same, right? I come out these two lines because this same thing, right? I want the server to have some feedback. So let's come out these two lines. Okay, do recover these two lines, and exactly the same, right? As we show in the slides, right? Let's see how TCP react. So first we launch the TCP server side. Okay, the server is ready to receive. Then, I mean, after this line, actually it's already been in listening mode. right? Still remember in the code before the forever loop, we have the listening, right? Listen, right? It has to listen to the TCP request. So if I launch the TCP client, it first establish the um, socket, right? And then to send the TCP request. After send the TCP request, the server side responds that, okay, TCP connection has been established, and send receive the data. Let's say TCPTS EE455. Okay, this is our course name. And okay, so you will server receive the TPT as the exact same thing and convert to the uppercase, and client side receive that. Okay, maybe we can add one more line to the server side. Okay, so let's add another line here. Let's say print TCP connection established. Okay, and in this side we can maybe also have a check. Okay, this side not, because you just send a request, it's accepted, you can send the data, right? So let's say here we save the code, and first launch TCP client, server. Okay, inside Python TCP client. Okay, so you can see after I launch the code, immediately TCP connection has been established, right? Nothing I need to input. Before that, connection has been established. Okay, immediately after I launch client side. And I say that, good morning, happy Friday, right? Good morning, happy Friday. Okay, and actually, the TCP connection or socket has been closed here. If I launch the client, I do something else, happy weekend. This is another socket in the server side, okay? Happy weekend. So maybe how can we demonstrate? We use a two socket. Maybe we can ask, before close the socket, let's ask the server to print socket. What about this? Okay, let's just ask the server to print the socket. Let's see if the socket, I launched two clients twice, right? If see the socket has changed or not. Okay, so TCP server. Okay, I launch the client. Okay, first TCP connection has been established. I say, oh sorry, I say hello Friday. Okay, it print a socket object. If I do another one immediately, hello weekend. You can see here, we have a totally two different socket, right? So these sockets are totally different because for each connection, for each server, so actually we launched two servers, right? Accurately, right? We launched two servers. So these two servers should have two different sockets, and these two different sockets should communicate with the server independently, with the client independently, okay? So let's see if any question asking here. Yes, definitely. You can keep the connection open and receive more data. but you have to make sure that the client side is not immediately end, right? So here I just close the socket, and if you want to do another one, you just do another one, okay? And after that, you close that, okay? And if you don't put if you don't put sorry, if you don't put close the socket connection here, right? You can receive multiple times of the data, right? You don't close the socket as a socket, right? Can this code work on this code? Yeah, I think so. I think it's across the different environment. It's just like a Python. Wherever Python can be running, Python 2 can be running, socket library can be import, then you should be fine. It's independent with your operating system, independent with your network setting, because just the local host, right? Local host is the um, um, yes, you can see here. So you can see here the why I use a local host, because this IP address for my own laptop, I set local host. You can change to anything else. But anyway, I think if you have a good setup in your laptop or desktop, this code should be definitely working. So I will upload this code to the Blackboard, okay? And you can play with that. And our next assignment will be based on this programming. Okay, our first programming assignment. How do you write code to be fine with the missing bits from UDP mesh since you are not checking that all the bits are being received? How does the server handle? The server doesn't handle receiving the missing information. As we mentioned, if you want to handle the missing information, you just use TCP. UDP is for the applications that okay with losing or missing information, as we mentioned, okay? If you are not okay, please do not use UDP, right? If you are not okay losing data, please use TCP. So UDP is just, like server side cannot guarantee I receive any data, right? You just get whatever you can get and to process the data, right? If you have to make sure the data cannot be lost, just use TCP. Okay, good question, but yes, I think UDP cannot. Yeah. You are running a game server and you are using the UDP. How do you have the server handle the missing bit? So here, what is the missing bits? So you mean the packet, some bits are missing? So in a one packet, some bit have not been received very well. So I think that's something we need to discuss in the UDP protocol. So there is some protocol to protect the bits in each packet or something there. Okay, but we are now talking about the packet beyond the packet level, or within each packet, you receive some or not receive some. That's the problem for the transport protocol itself inside. How to develop that protocol? That's the next chapter's content. Okay, so we can cover that later. Okay, so thank you everyone to attending that today. That's it. I have a meeting on 11, so let's end a little bit earlier than before. Okay, thank you everyone. So hope you enjoy your weekend, and I will upload every code and demos, videos to the website, and you should play with that after the assignment too. It should be a programming assignment. Okay, be prepared for that. Okay, thank you everyone. I'm one with I think the grade for assignment is already back, right? So if you haven't heard that, maybe something wrong with your submission or wrong with the TA. I think the TA told me every grade has been uploaded. Okay, so double check, please double check. If you haven't seen that, tell us. Okay. Okay, so okay, that's it. Thank you everyone. Have a good day. Bye bye.